Hello, class. All right, today we have a fun activity planned in class where you're going to be making your own polyhedrons. And so a lot of what we do is going to be done in class. But there were a few things that I wanted to go over here just for you to be aware of. So you can see we have polyhedra called prisms here. They're prisms, and that's A through F. And then for P, Q, R, and S, those are pyramids. Okay, so we wanted to know about the characteristics of prisms and the characteristics of pyramids. Okay, so let's look at some things that you might notice. Let's see, for one thing, if you look at the prisms, you might notice that a prism has rectangular faces. You should be able to see that, rectangular faces. And some of those faces are parallel to one another. But as you can see here, it doesn't have to have all of the faces be rectangles. You can have two faces that are not rectangles. So that's something we want to note there. Make this a bigger text box. Okay, so those are some observations about the prisms. For pyramids, here are the pyramids down here, P, Q, R, and S. Okay, so let me scroll down a little bit here. We're just looking at the pyramids. So some things you might have noticed about that. Pyramid is going to have a triangle for all of its faces, or it can maybe have one face that's not. So let's add in that text here. Okay, a pyramid, not pyramid, a pyramid has triangles for its faces, may have one that is not a triangle. Okay, and if it has a face that's not a triangle, all of the triangles that are a part of the polyhedron are going to share an edge with it. So all triangular faces share an edge with it. Okay, let's stretch this out here. Okay, so those are things to note. And also, all triangles meet at a single vertex as well. So you can see that. Let me add that in. Let's make this all smaller. Okay, so all triangles meet at a single vertex. Okay, and then another question that was important here. They said they have some what they call nets. Okay, they call these nets. A net is a two-dimensional representation of a polyhedron. Basically, the idea is if you think about sometimes you might get like a cardboard box, and it might come in and it might be completely flat, and then you're going to take that box and you're going to kind of open it up and make it into something like you see up here, right? And so we want to try to picture opening these up to get them to look just like, in this case, they want us to focus on letter P. So if you look at this here, we want to notice, first of all, look and see how many faces there are for P, because it's going to have that number of faces in our net. So if you look here, we can see 1, 2, 3, and then 4. There's 4 of them. So net 1, does it have 4? It does. And then the idea is this is kind of the bottom here. The bottom is going to be a triangle. And so we need to have it set up to where we can have a bottom that can be the triangle, and then 3 triangles can rise up from that as the faces. And if you look here, you totally use that. We can totally have one of these be the bottom, and then sort of pull the other 3 up around it like that. So for net 1, this would work. We can say that, yeah, this would work for P. Okay, And then for net 2, if you look at net 2, does it have 4? 1, 2, 3, 4. Yep, there's 4. And could we use 1 as the bottom and have 3 coming around it? Well, yeah, we could. This one looks like it would be the bottom, and then these 3 would rise up from the ground or from the bottom up, and then you can have it looking just like figure P does. So net 2 also would work. It's got four faces, and we can set it up just like that. If we look at net 3, does it have 4 faces? 1, 2, 3, 4. It does. Is there going to be a way to use one of these as kind of the bottom and have everything rise up like we see here? As it turns out, there's no way to make that work. It's not going to be able to be put together the way P is. If you look at that, there's no way to make anything of the triangular bottom or base and then build around that. It's going to be sort of an odd figure. It's not going to work out. So net 3 would not work for pyramid P. Okay, so the rest of the activity is just going to be in class. These are questions that your answers are going to vary based on your own polyhedron that you're working with. All right, we'll go over this more in class. All right.